Well, ladies and gentlemen, let me kick off this event by introducing our very first of our 10 finalist companies for this particular iTech Challenge cycle. Let me introduce 10-9 Technologies out of Tulsa, Oklahoma.
Hi, welcome everyone. Good morning. My name is Ashley Schaefer. I'm the head of cell development with 10-9 Technologies, and I'm excited to talk with you today about TENIX. It's a battery active material. It's a nano additive for power boosted cathodes. Now, I don't have to remind NASA about the importance of batteries. Shown here is a final transmission from the Mars Opportunity rover after an impressive 15 years of operation on the red planet. From the smallest IoT application to grid storage and electric planes, our devices are only as good as the batteries that power them. And inside these batteries, sight unseen, are the materials that control a battery's performance. Active materials undergo chemical reactions that enable the battery to charge and discharge. And it is this invisible world of atoms and electrons that ultimately control our electrified future. And in order for us to have this electrified future that we dream of, with extended range EVs, electric planes, more sustainable power generation, and reduced waste, it's the battery that must deliver it. And in order for the battery to meet these necessary requirements, we must focus on the materials where these chemical reactions are happening inside the battery. Introducing TENIX. It's a cathode active material and 10-9's flagship product. Our proprietary patent-protected nanomaterial, when blended with traditional cathode active materials, can significantly boost performance of both primary use and rechargeable batteries. We believe TENIX is a means to an electrified future, as well as to a means for more sustainable power across all devices. We're a material science company. It is our mission to deliver battery materials that are industry leaders in both their provision of energy and in their profile of sustainability. And we have a strong team to help deliver this. We have a diverse group of individuals from a variety of backgrounds, all working together towards the same goal. We were founded in 2014 in Tulsa, Oklahoma by our CEO, Paige Johnson. She has a background in chemistry and an innovative mindset. Our corporate values are curiosity, generosity, and authenticity, and they drive our progress. We aim to tackle the big problems of the world through nanomaterial development. We've already scaled to tonnage production because we value practical and sustainable manufacturing methods for the materials that we're developing. In case you weren't aware, active materials play a huge role in the battery industry. Active materials have the highest margins in the battery value chain, and they can affect upstream and downstream decisions. They also impact various industries, from battery pack manufacturing to mining, to the development of applications that use batteries for power. The market value just a few years from now is projected to be $75 billion, and we believe we can secure a portion of this. Now, it's fair to say that there are other players in the battery materials space. As a refresher, a lithium-ion battery consists of two opposing electrodes, your anode and your cathode, an electrolyte that shuttles lithium ions between the two electrodes during charging and discharging. Many of the other companies working in the space are focused on anode and electrolyte development. To our knowledge, 10-9 is the only company working on an entirely new cathode active material proposed for the EV and aviation markets. We believe we could uniquely impact these markets while also creating a unique financial opportunity by working in a space with less competition. We have a unique approach in that the company was formed around the invention of materials. Many companies are working at technology, but it's licensed from universities or from other entities, whereas 10-9 is working on wholly owned technology. Now, traditional research in the cathode electrode space has focused on increasing stability of existing materials at higher voltages for just incremental gains in power and energy. 10-9, on the other hand, has developed a novel material synthesis method, which has led to increasing the capacity of materials via increased surface reactivity, and resulted in a new class of high-energy materials. To date, we've been granted 8 patents, 7 in the US and 1 in Japan. This new class of materials is both nickel and cobalt free and can be produced within a net zero carbon footprint. This leads us to our unique business plan, in that all batteries impact climate, and we plan to impact all batteries. As mentioned, we have an entirely new active material proposed for the EV markets. And these rechargeable systems, replacing just a portion of the traditional cathode active material with TENIX, can reduce both the social and environmental impacts from production of those materials, like nickel and cobalt. But let's not forget about single-use batteries. 75% of all batteries sold globally are single-use, particularly in the developing world. Doubling the lifetime of these batteries would halve their waste, and that would be equivalent, based on carbon emissions, to removing 1.3 million internal combustion engine cars from the road each year. CoinCell results from our third-party labs using our 10% blend strategy, where 10 weight percent of the traditional cathode active material is replaced with TENIX, have shown up to double the lifetime in single-use batteries and up to double the peak power in the rechargeable batteries. On the left, you'll see full discharge data at 24 milliamps in coin cells for lithium manganese dioxide control and blended primary batteries. And on the right is pulse power data from NMC811 control and blended rechargeable batteries. These are disruptive and impactful performance gains simply by dropping in a new material during the electrode fabrication process. The high power demands necessary for electric flight create an opportunity for TENIX blended systems. Looking at pulse power data, we're going to go through projections in a 21700 cell format for eVTOLs, electric vertical takeoff and landing vehicles. We're seeing at a low pulse rate, so those rates that are equivalent to cruising operations for an eVTOL, a 225 watt-hour per kilogram cell could deliver 3 times the peak power in a blended NMC811 and TENIX system compared to a control system with just NMC811. And at higher rates, such as those that you see during takeoff and landing, we're seeing 2 times the peak power in a blended system as opposed to a control. And even though we're removing 10 weight percent of the active material, the capacity of the battery doesn't suffer due to the surface reactivity of TENIX. We're seeing comparable specific energy values in both the blended and control batteries. This intrinsic power capability of TENIX doesn't just affect flying conditions, but can also lead to decreased charging rates, which means you can have faster refueling and improved turnaround time between trips. Across all states of charge, we're seeing that increased power capability happens with the addition of TENIX. Throughout the various chemistries and cathodes that we've been testing, we're consistently seeing that TENIX is strongest where the traditional cathode active material is weakest, at low states of charge and at high rates. While we have a deeper understanding of this eVTOL space, as we're currently undergoing a qualification trial with a major eVTOL company, the performance gains shown here can apply to other electric aircrafts, such as UAVs and single-aisle planes. The improved power capability of a TENIX blended system can reduce both the mass and volume of an aircraft's battery pack. Current battery systems have high polarization due to resistivity within the system that leads to a less than ideal drop in voltage when high power is drawn from the system. This means that while a battery may have plenty of energy available at low current demands, when the demand for current or power increases, the energy available in the system decreases, and thus a battery must be oversized to meet these challenging conditions. Not only does the main battery need to be oversized, but emergency battery packs carried by an electric plane must also be sized appropriately to meet these high power conditions, leading to additional weight in the aircraft. The power potential of TENIX, blended with an energy-dense cathode, can reduce energy loss under high load, leading to improved rate capability at a reduced system's mass. So, to recap all of that technical jargon, let's go through the main points and how TENIX can revolutionize flight. We expect longer flights because we have increased power at lower states of charge. We expect smaller and lighter battery packs via the increased energy that's available due to the reduced drop in voltage. We should see faster turnaround times because we have increased charging capabilities. And we expect lighter thermal management systems because of that reduction in resistance, which means we have less heat generation within the system. 10.9 has been gaining traction and entered into multiple customer agreements or evaluation trials with various customers, not only because of the potential performance and sustainability improvements, but because we are ready. TENIX has been scaled to tonnage production within a net zero carbon footprint. Today, we have the ability to produce 24 tons annually at our pilot plant in Tulsa, Oklahoma. Readiness is a major problem in the battery tech space. Proposed technologies are developed at small scale, but they have struggled reaching the volumes required for large trials, much less market entry. Looking at some of the other players in the space, on just $11 million, TEN9 has developed and scaled TENIX to quantities that could put 3,000 electric vehicles on the road next year using our 10% blend strategy. As you can see, there are plenty of other companies that have received hundreds of millions, if not billions of dollars, yet they still have a ways before their tech will be driving on the road. It's an exciting time for TEN9. With tonnage production, we're poised for market entry. During the first 4 years of the company, we focused on inventing and protecting our technology. And over the past 3 years, we've been focusing on the market fit. We pivoted to a de-risked implementation strategy where TENIX is blended with a traditional cathode active material rather than marketing TENIX as a standalone active material. Since testing began on these blended systems, we've entered into multiple qualification trials in both the primary and secondary battery space. We are now ready, and we are at an inflection point of both value and revenue. To summarize, we have a cost-competitive cathode active material that we believe can significantly impact the electrified future. With TENIX, we have a disruptive invention leading to a market paradigm shift based on our entirely new approach to battery material synthesis. We have produced a battery material with a new balance of power and energy than exists with conventional materials. We present a de-risked implementation path with rapid market entry via our blend strategy. We are currently accepting pre-orders for 2022 production. We're also in the process of raising $30 million for our Series B round, which will be used to expand production to increase those annual volumes of our material. If you're interested in learning more, please feel free to contact me. And we're also accepting inquiries for interested investors. Thank you for your time. Once again, I'm Ashley Schaefer with TEN9 Technologies, and I'll open the floor for questions.